Here's our third question on the retrieval practice. With tan theta equal to 1, which of these is true? Theta lies in the first and second quadrants. Let's have a look at the quadrant diagram. We have all of them are positive here. Sine is positive in this second quadrant, tan in the third, and only cosine in the fourth quadrant. So the first and the second quadrants, we can have the first quadrant where tan is positive, but not in the second. So this A is not a correct statement. The principal solution is theta equal to pi over 4. Well, we do know pi over 4 is 45 degrees, and tan 45 or pi over 4 is equal to 1. So that could be, but how do we know that it is a principal solution? This is key here, not just the solution, but the principal solution. What is the principal solution? Let's look at the definition for tan theta. This is the interval in which theta must lie. And there's only one solution for tan theta equal to t. In this case, t is equal to 1. And it must occur in this interval. So pi over 4 as the value theta occurs within this interval, and so it is not just a solution but the principal solution. So the definition is very important here. What about cosine theta equal to root 2? Well, cosine, now we know what theta is. Cosine of pi over 4 is actually root 2 over 2. And so C is not a correct or incorrect statement. It should be cosine of theta, which we know is pi over 4 is root 2 over 2. And that's it for retrieval practice today. I'll be coming up with some more questions over the next few days. Thanks for watching this video. My name is Alistair. Bye for now. Hello, welcome to the second question on retrieval practice. Pi can represent which of these? Is it the ratio of the circumference to the diameter of a circle? B, half a revolution? C, the period of the function f of theta equal to or equivalent to tan theta? Or D, the angle whose cosine is equal to 0? Let's look at the first option, the ratio of the circumference to the diameter of a circle. We do know the circumference C is equal to 2 pi r, which is equal to pi d. So if we have the ratio of C to d, we have pi. So that indicates that A is correct, a correct statement. What about B, half a revolution? So we know a full revolution is 2 pi. So half a revolution is half of that, which is pi. So B is also correct. The period of the function f of theta is equivalent to tan theta. Just a sketch a little graph here to show you what this looks like. So if we have our lines here, so this is at pi over 2. This is pi next one here is at 3 pi over 2. This is theta, and this is f of theta, which is tan theta. Roughly look at just a rough sketch to show you the graph of tan theta. And we have a period here going from 0, and the next one occurs at pi. So the period of f of theta equivalent to tan theta is a period of pi. So this one is correct also. What about the angle whose cosine is 0, or cosine of pi is not 0, it's -1. And this is the exercise, so you just sketch the graph of the cosine function, and you'll see that cosine pi is -1 and not 0. Thanks for watching this video. My name is Alistair, and I'll see you in the next one. Bye for now. Hello. Today's videos are going to be on retrieval practice, and this is based on the last few weeks of videos based on trigonometric functions. If tan theta is equal to 1 and cosine theta is negative, by the way we're talking about the same angle theta, then which of these 4 options is true or are true? Sine theta is positive, cosine theta is minus root 2 over 2, cot theta is equal to -1, or sec theta is negative. Well, let's look at the facts. If tan theta is equal to 1, we have a quadrant diagram, and we know that all the ratios are positive in this quadrant, the first quadrant. In the second quadrant we have sine as positive, in the third only tan, and in the fourth only cosine. Now if cosine is negative, then it cannot be in this quadrant, because all the ratios are positive in the first quadrant. So it must be in, and it's positive, tan theta is positive, so the only other quadrant where tan theta is positive is in the third quadrant, and that's this quadrant. So if we were to, let's just include the angles now in our quadrant. So it's not in this quadrant here, but this is tan, let's call this tan 45, sorry 45, the theta being 45, so tan inverse of 1, which is 45. So the only other quadrant where it's positive and where theta is negative will be in this quadrant. And in order to get to this angle, we're measuring from positive x-axis in the clockwise direction, and this angle theta is minus 135 degrees. So it's not tan 45. Theta is not 45 degrees because cosine will not be negative in the first quadrant. In this quadrant it's positive, and the only other quadrant where it's tan is positive and cosine will be negative is in the third quadrant. And so we have 100 minus 135 degrees is theta, so theta is equal to minus 135 degrees. Now we need to answer let's check the first option here is sine theta positive. Sine theta is positive only in this quadrant, so this is not one of the options that is correct. What about if cosine theta is minus root 2 over 2? Well, we know that theta is minus 135, and if you do cosine of minus 135 degrees, you can use your calculator for this. This gives you minus root 2 over 2. So this is the correct option. Now what about C? Cot theta is equal to minus 1. Well, we know tan theta is 1 and cot theta is simply 1, the reciprocal of tan theta. So that would be 1 over 1 is equal to 1. So this is not correct. C is not correct as tan theta equal to minus 1. What about sec theta being negative? Is that true or false? Well, what is sec theta? Sec theta is equal to the reciprocal of cosine theta. Let's write out where you can see it. So sec theta is equal to 1 over cosine theta. And we know that cosine theta, we've confirmed that, given that it's negative, so its reciprocal will be negative. And so this will be equal to 1 over some negative value, which will make it negative. So option D is also correct. So let's just recap. We're given that tan theta is equal to 1 and cosine theta is negative. It cannot be in the first quadrant because all the ratios are positive in the first quadrant. The only other quadrants where tan is positive and any other ratio is negative is in the third quadrant. And that gives us the secondary value of minus 135 degrees. And that allows us to work out what cosine theta is. When we put that cosine of minus 135, we get minus root 2 over 2. Cot theta cannot be negative 1 because the reciprocal of tan theta is just positive 1, shown here. And lastly, sec theta is negative. If cosine theta is negative, then the reciprocal of cosine will also be negative. And that's it. Thanks for watching this video. My name is Alistair. I'll see you on the next one. Bye for now. Hi, today I'm introducing a new type of tutorial. It's not about doing so much of working out, but it's to do with retrieval practice. Very important for learning anything that you want to learn. So I have 3 statements here. I would like to determine whether they're true or false. So first says the inequality x adds 7 is greater than 3 is satisfied by a finite number of values of x. Well, if we were to find the solution, we have x is greater than 3 minus 7, x is greater than negative 4. And what we know there are infinite number of values of x greater than negative 4. So we know this statement is false. We'll write a big F there. It's a false statement. Next we have the equation ax squared add bx add c is equal to 0 has two roots. Well, we do know that it's a quadratic equation and they do have two roots, and that's indicated by the index here of 2. So this is a true statement that the equation has two roots. And lastly, the line 3y equal to 7x minus 2 has an intercept of -2. Well, let's go ahead and rearrange this in standard form. So 3y equal to 7x minus 2. Y is equal to 7 over 3 x minus 2 over 3. And we know this is in the form y is equal to mx add c. C is the y-intercept, and we can clearly see y-intercept is -2 over 3, which makes this statement false. So this is a false statement. This one is true and this one is false. Thanks for watching this video. Retrieval practice is very important. I'll be mixing retrieval practice along with practice problems in my videos. I hope you find it useful, not only for mathematics but for any subject that you want to study. Practice, practice, and practice some more. Bye for now. Hi. Today I'm introducing something new to help you to improve your studying of mathematics, and in fact any subject, and this is called retrieval practice, where I'll put a set of statements, I'll give you some information and then ask you to check and determine whether the statements are correct or not. So here we have 3 statements, and the information given is that the equation of a line k is 7x minus 2y add 4 equal to 0. And first we need to determine whether k has a gradient of 3.5. So we'll rearrange this in standard form, and this becomes 2y is equal to 7x add 4. So y is equal to 7 over 2x add 4 over 2. So that's 7 over 2x add 2. So our gradient is indeed 3.5, same as 7 over 2. So we know that this statement is correct. Next, we have k is parallel to 7x at 2y minus 3. The condition for two lines to be parallel is that they must have the same gradient. So let's rearrange this and see if we have the same gradient, 7 over 2 or 3.5. So we have 7x at 2y minus 3 is equal to 0. 2y minus 7x at 3. So y is minus 7 over 2 at 3 over 2. We can clearly see this is a negative gradient, negative 7 over 2, and this is positive 7 over 2. So that statement that k is parallel to this line is not correct. And lastly, we have that k is perpendicular to 2x at 7y minus 5. The perpendicularity condition states that the product of the two lines must be equal to -1. So we'll find the gradient of this, multiply it by the gradient of this line, which is 7/2 or 3.5. So let's find the gradient of this one. So we have 7y is equal to -2x at 5. So y is equal to -2/7x at 5/7. So we have a gradient of -2/7. So m1 is 7/2 and m2 is -2/7. So the product m1 m2 is equal to 7/2 times -2/7. It cancels out to give us -1. So K is indeed perpendicular to 2x at 7 minus 5. So the statement is correct. Thanks for watching this video. Make sure you do as much retrieval practice as possible. It's going to help you tremendously. Keep practicing as much as you can. Bye for now.